All right, welcome back. Today, we're going to get our hands dirty, so to speak, with a real titan of the battlefield, the Soviet Giatsint-B. We're going to break down the absolutely incredible mechanical symphony that makes this classic piece of artillery so devastatingly powerful. So, let's dive right in.
So you look at this thing, this massive piece of steel, and you have to wonder, right? How does a team of soldiers actually operate it? How do they turn it into a precise, long-range weapon? Well, I can tell you, it's a whole lot more than just pulling a trigger. It's this carefully choreographed dance of pure strength and pinpoint precision. Let's walk through it together.
Okay, first things first. Let's meet the star of our show. Its official name is the 2S5 Giatsint-B. A bit of a mouthful, right? But it's also known by its much more poetic Russian nickname, which actually translates to hyacinth.
So this thing was designed way back in the 1970s, and it had a really specific job. Its whole purpose was to sit back, outrange, and just destroy enemy artillery. That's a role we call counter-battery fire. And, on top of that, it was built to smash through fortified targets. So don't think of it like some brawler up on the front lines. Oh no, this is the long-distance, heavyweight champion.
And when we say long distance, we mean it. Get this, 28 kilometers. Just let that number sink in for a second. That is over 17 miles. We're talking about hitting a target that is completely out of sight, way, way over the horizon. It all comes down to pure math, coordinates, and calculations. From that kind of range, you can imagine it just creates this huge zone of control on the battlefield.
But, a weapon like this is just a chunk of metal without its crew. And operating the Giatsint-B is absolutely not a one-person job. It is a full-on team effort. It takes incredible strength, pinpoint precision, and just perfect coordination. Seriously, it's less of a task and more like, well, a mechanical ballet.
Okay, so before you can even think about firing, you've got to anchor this beast to the ground. The first thing the crew does is deploy these huge split trails. That creates a really stable base. Then, and this part's really clever, they lower a central firing platform which actually lifts the wheels right off the ground. Now, why do that? It's absolutely crucial. And make sure that the insane recoil from firing doesn't just send the whole gun skittering backward. Only after all that's done can they finally aim the barrel and get the breech ready for a shell.
All right, now we get to the real heart of this weapon's power, the ammunition. And I'm going to tell you, it is not what you probably think. We're not just talking about some giant, oversized bullet. No, this system uses something called two-part, or separated ammunition. So it's broken into two distinct pieces. First up, you've got the projectile. You can think of this as the what. It's the thing that actually hits the target. And this shell is, well, it's a monster. It weighs a staggering 90 kilograms, that's nearly 200 pounds, and it's just packed with high explosives. Then you have the propellant charge. This is the how. It's a separate case filled with the explosive that actually fires the shell. And what's cool is that by using different sized charges, the crew can fine-tune the range of the shot with incredible precision. Okay, let's set the scene. The gun has locked down and stable. The crew has their target coordinates. The ammo is ready to go. Now, it's time to bring it all together. This is that final, powerful sequence of actions. This is where all that hard work pays off.
And this final sequence, it's this amazing mix of pure brute force and surprisingly elegant mechanics. First, that massive 200-pound projectile has to be physically rammed down the barrel. Then, the propellant charge is loaded in right behind it. And here's where the magic happens. A huge chunk of steel, the breech block, just swings shut all on its own, sealing the chamber perfectly. And the final step? After all that, it's surprisingly simple. A soldier just gives a sharp pull on a long cord, called a lanyard, and that's what triggers the firing pin. Boom.
That whole process, it just perfectly captures what this thing is all about. This is not some delicate high-tech gadget. Not at all. It's a machine built on raw mechanical power and just unbelievable reliability. It was literally designed to work in the mud, in the snow, in the blistering heat, and to just keep working, every single time. Which, of course, brings up a really interesting question. Why are we still talking about a weapon that was designed back in the 70s? I mean, what gives it this kind of staying power in the 21st century? Well, the answer, it really comes down to its core design philosophy. Here's the key takeaway, really. Its greatest strength is its simplicity. The mechanics are just so robust, way less complex than a self-propelled gun, which is basically artillery built onto a tank body. And what does that mean? It means fewer things can go wrong, and it's a whole lot easier to fix out in the field. So you take that rock-solid reliability,
You combine it with the raw power of a 152mm shell and that incredible range, and what you get is a weapon that is still brutally effective even decades later.
And that leaves us with one final, pretty deep question to think about. We live in an age of smart weapons, right? Precision missiles, stealth aircraft, autonomous drones. So, in a world like that, what is the role of just raw mechanical power? What place does a weapon like the Giatsint-B, this symphony of steel, muscle, and gunpowder, still have on the modern battlefield? It's a really fascinating question, and it gets you thinking about the very nature of power itself.